Chapter 6, Section 1, we're going to start learning how to verify identities. Um, the process that you're going to be using to do this is not solving. The point isn't to find X, it's to prove that something is what it is, okay? And the process that you're going to learn doing the algebraic processes with trig functions and using trig identities to change the way something is written is extremely, extremely vital to you being able to do things in the future in your calculus classes. So even though it may seem like you're not accomplishing anything, it is hugely important that you practice this and learn how to do it. Okay, so far, the identities that you know and need to be able to use are the reciprocal identities. Secant is the reciprocal of cosine. S goes with C, C goes with S. So cosecant is the reciprocal of the sine. You're going to find a lot of value in replacing cosecant and secant with the sine and cosine form forever and always, amen. Okay? The very best thing that you can do in these problems is to change everything to sines and cosines right at the beginning. Okay? We also know that the cotangent and the tangent are reciprocals of each other. That one's not quite as useful. The ratio form of the tangent and the cotangent in terms of sine and cosine are what is most important. Cotangent has cosine on the top. All of these are super, super important, okay? The next most important thing are your Pythagorean identities. Because of the Pythagorean theorem, x squared plus y squared equals r squared, we can prove that sine squared plus cosine squared always, always, always equals 1. And you can get this identity in other forms using the other trig functions, tangents and cotangents, secants and cosecants, by just dividing this through by, say, sine squared. If I divide everything by sine squared, I get 1 plus cotan squared equals cosecant squared. If I divide everybody by cosine squared, I get tan squared plus 1 equals secant squared. So because we're going to be changing everything to sines and cosines, you don't use these as much, but it is still good to know them and practice them. So the way I remember is tangent and secant are in a family because they both have cosine in their denominators, right? You see it right here. Tangent and secant belong together. So tan squared plus 1 equals secant squared. And I just always remember that secant is the sum. And I remember what family goes together. The other one, if you divide through by sine squared, you see that cotangent and cosecant are in the same family because they both have sine in the denominator. So the other form of this is cotan squared plus 1 equals cosecant squared. You see that both of these identities have the same form, where the ratio of sines and cosines here squared, everything is always squared in these, plus 1 equals the reciprocal of the sine or cosine here. Okay? All of this is derived from this. You also need to see that 1 minus sine squared is cosine squared. This does not work if they're not squared. 1 minus cosine squared is sine squared. Okay, so you need to be able to use all forms of this. Sometimes you'll be working verifying an identity, and you'll end up with this, where you can just replace it with cosine squared, or this and replace it with sine squared. Sometimes, not very frequently, but sometimes you'll have something like sine squared and you'll have to replace it with this and maybe factor that. This is the difference of perfect squares. All of your algebra skills are going to be used. You'll just be doing things with sines and cosines using these identities to make one side of an equation look like the other, not to solve, but to verify. You're proving something with these problems. Okay, the other identities that you've learned that you might need in this section, and you definitely need to remember because they're useful. You just don't see them as often, are the cofunction identities, where the cosine is the cofunction of the sine, and that relationship just means a 90-degree difference. Okay, think about it. If you have a right triangle, if one of the angles is x, the other angle is 90 degrees minus x. And all you're doing is flipping adjacent and opposite. All right. Same thing with the tangent and the cotangent. Another thing that's important to remember is the even and odd properties. Cosine, if I go backwards, gives me cosine if I go forward. Sine, if I go backward around a circle, gives me the opposite, the negative of what I originally had. And this works for any angle. It's just always the way it is. So if you need to know tangent of minus, then you just take sine over cosine and you get negative tangent. So you should be able to use these things up here to derive all of these, and then we're going to add to this. All right, let's get down to what we're actually doing. Okay, some quick tips for doing what you got to do here. First off, remember that this is not solving equations like you did in algebra. You're just going to use algebra to prove something, okay? So you need to pick a side and stick with it. You want to pick one side of the equal sign that gives you the opportunity to actually do something. If you just have sine on one side of the equal sign, there's not much you can do to it. But if you've got secants and cosecants and tangents and cotangents and things like that, changing everything to sine and cosine gives you the opportunity to find common denominators and mess with stuff. And then I'll give you the number one rule at the end of this, okay? You never cross the equal sign. This is not solving an algebraic equation. You're going to pick a side, stick with it. You're going to mess with that one side of the equal sign until it is the same as the other side. You're verifying that two things are equal to each other by changing the form in which it's written. And like I said, the easiest thing to start with is to change everything to sines and cosines. If you've got any of the other four trig functions, they're fractions, which means that you can get common denominators and you combine things, and you're always, always, always looking for the opportunity to change the way something's written because of an identity. If you end up with sine squared plus cosine squared, then you can always just change that to a 1 because of the Pythagorean identity, okay? Above all, you have to be fearless. You don't have to know the answer before you start working the problem, okay? I don't know how something's going to work, and I've been teaching this for forever, okay? Because I'm old. You just have to pick a side and start messing with it. Sometimes you may think that you picked the wrong side. You want to start over with a new piece of paper, okay? There's nothing wrong with that. Sometimes I cheat a little bit and I get bogged down, and I'll start working the other side until I see what I need to do to make what I was doing originally work the way it needs to work, okay? Sometimes you're going to take a whole page to solve a problem. Sometimes that same problem, you'll be able to do it in 2 or 3 lines, okay? All of these can be done in different ways. The more you practice, the easier it gets to know the easiest way to start, okay? But you have to be fearless, and you have to be creative. Like I said, you don't have to know the answer before you start working the problem. That's not the point, okay? You just have to pick a side and stick with it, never crossing the equal sign, because you're proving that the two sides of the equal sign are actually equal. You're going to want to change everything to sine and cosine. Some people don't do that. It's always easier though, because that gives you fractions. And when you have fractions, you can find common denominators and look for identities. Okay, here we go. What we are going to be doing is you'll be given an equation like this, and you want to show that this is true. You want to prove this. So you're going to pick a side. There's not much I can do to this. All I can do is rewrite that as 1 over cosine. I need to keep in mind that that's what it is, because 1 over cosine is what I'm looking for on this side. There's more going on here because I have 2 separate functions multiplying. So because there's more going on here, I want to pick this side and I'm going to stick with it. And I'm going to mess with it until it is this. That's the point of these problems. So the first thing I'm going to do is change everything to sines and cosines. Cosecant is 1 over sine. S goes with C and C goes with S. Tangent is sine over cosine. I'm not going to do anything to the right side. Now you see I have a sign on the top and a sign on the bottom that cancel. Multiplying straight across, I get 1 over cosine of x. And 1 over cosine of x is secant. And that is all there is to it. You're going to take one side and mess with it until it is the same as the other side, okay? Now that was pretty straightforward, pretty simple. Let's try another. Cosine, cotangent, plus sine equals cosecant. All right, pick a side. I'm not going to pick this side. There's nothing going on, but I got lots of stuff I can do over here. So I'm going to change everything to sine and cosine. So I get cosine. Cotangent is cosine on the top, sine on the bottom. I'm going to add a sign, leave the right-hand side alone. This gives me cosine squared over sine plus sine. Now, get a common denominator. The only denominator to choose from is sine, which means I'm going to multiply this guy by sine over sine. Left-hand side, or the first term, is already over sine. Multiplying by sine over sine gives me sine squared over sine. And now I look for an identity, right? I I changed everything to sine and cosine. I got a common denominator. Now I see on the top the sum of sine squared and cosine squared equals 1. 1 over the sine is the cosecant, and I have verified that identity. So, not that bad, right? Okay, let's try another. Sine minus sine times cosine squared equals sine cube. All right, everything is already in terms of sines and cosines. I don't have any fractions. I don't see any identities right in my face. I don't want to do this side because he's pretty simple. I want to do this side. Because there's no fractions and I can't change anything, I have to look for a different tactic. And I see that I have all signs on the right-hand side, and on the left-hand side I have two terms, both with a sign. So I'm going to just factor, simply because I don't have anything else that I can do. I have to be fearless and creative, all right? I have to just see that there's something I can do, and look what happens. 1 minus cosine squared is sine squared. That gives me sine cube, and I'm done. All right, this one is a little bit different. It's a little more complicated. There's not much I can do to the left-hand side. He seems pretty simple. On the right-hand side, I can change everything to sines and cosines, and then get common denominators. So I'm just going to see what happens. I may have to back up and do the other side and just be fearless and creative, right? But for now, cosecant is 1 over sine. Cotangent is cosine on the top, sine on the bottom. I have a common denominator. And where I feared that this would be difficult, turned out to not be difficult at all. If I had started with the left, I would have had a little bit more trouble. But you see that you have only one term on the denominator. In addition, in the numerator, I could have said that that's 1 over the sine plus cosine over the sine. That would have given me this and this. So, simple problem all around. Sorry to disappoint. Thought it was going to be difficult. Let's try a different one. Maybe we can find one that's a little more challenging. Sine x over 1 plus cosine x plus 1 plus cosine x over sine x. Holy cow. Equals 2 cosecant x. Well, well, well. This can be changed to 1 over sine, but this looks like it's more fun to mess with. And what can I do to 1 over sine, right? So on this side, I'm going to pick it, and I'm going to get a common denominator. So my common denominator is just going to be sine times 1 plus cosine. No other choice. So the first fraction is sine that was here times this sine. I hope you guys remember how to find common denominators. This fraction needs to be multiplied by this guy on the top and the bottom. So I'm going to end up with 1 plus cosine times itself. And I'm going to write this out because it has to be FOILed. You can't just square. It's this squared, right? You can't just square the pieces. If it's 1 plus cosine times 1 plus cosine, it has to be FOILed. Don't be lazy, you got to FOIL, okay? So here we go. I have sine squared plus, thank goodness it's plus, I don't have to distribute a minus sign. FOILing this guy out, I get 1 times 1. My outers here is 1 times cosine, inners is 1 times cosine, so I get 2 cosines. And the last times the last is positive cosine squared. All right, we have our common denominator. Remind yourself of what you're looking for. We're looking for a 2 times a 1 over sine, all right? Not there yet, right? This guy is going to stay in the bottom. It looks like this guy should cancel at some point. There's nothing common on the top. The only thing I can do is take the cosine squared and the sine squared, put them together, and that's a 1. There's my Pythagorean identity. Putting those together gives me a 1. That 1 gets added to this 1, and I have 2 plus the 2 cosine x over sine 1 plus cosine. Do you see it yet? I'm going to factor a 2 out of the top. 2 times 1 plus cosine x. Glory be over sine x 1 plus cosine x. See how stuff just works? Bang, bang. I get 2 over sine. That's 2 cosecant. Exactly what I was looking for. Okay, so far we've seen problems that if we just change the sines and cosines, stuff cancels. We've seen problems that we've had to get common denominators. We've seen problems that we've had to factor. And you're always looking for Pythagorean identities. And remember, sine squared plus cosine squared equals 1 is the main identity that you're going to get, because the first thing you're doing is changing everything to sine and cosine. Then you get a problem like this. There's not much you can do to either side, right? So, and remember, we're not going to cross the equal sign. The book will tell you to work each side, but don't, okay? And we can't like move this over and get a common denominator and stuff like that. We have to pick a side and stick with it. So I want to show you a trick here. I'm going to put a little blue thought bubble over on the side here. If sine squared plus cosine squared equals 1, then 1 minus sine squared equals cosine squared. Okay? But this is the difference of squares. And you can do this the other way with the cosine squared. Whenever you factor the difference of squares, you get what's called conjugate factors. Okay? Whoops, I made a mistake and you didn't say it. You get conjugate factors. So notice that if I have something like this, and if these were cosines, it would work as well. You just get 1 minus cosine squared. If I see a factor like this, I can multiply it by that and end up with something simple. Okay? So either one of these sides I can multiply by the conjugate. I'm just going to stick with the left-hand side because it's just what I do. Okay? So I'm going to take this fraction and multiply the top and the bottom by the conjugate of the bottom. There's not much I can do to the top, but if I do anything to the top, I have to do the same thing to the bottom because I can't change the value. Now, it's the bottom I was messing with, so I'm not going to multiply out the top. I'm going to leave it the way it is and see what happens. On the bottom, when I FOIL that out, you see that I've given myself the difference of squares here. So it's 1 squared minus sine squared. Oh, looky there. I have an identity. So now I can change the bottom, not messing with the top. I can change the bottom to cosine squared. And now, because I didn't multiply out the top, I can just cancel. And I'm left with 1 minus sine on the top and cosine on the bottom. And that's exactly what I was looking for. So the process of multiplying by the conjugate comes in handy. Seeing that these things can be factored in the first place sometimes will help you cancel things out and change the form so you can verify the identity. All right, this one's a little bit nasty and it's got some stuff in it. Stuff that's easy to manipulate. This side, he's pretty much done. So I want to obviously mess with this side. So I can change everything to sines and cosines. But something I haven't pointed out yet, if the angles are not the same, then you can't do anything. Okay? If the angles are not the same, you can't do anything. However, you have identities to deal with changing your angles. This is the, if you go backwards thing, remember sine is opposite, cosine stays the same. So this is 1 over the sine. So if I go backwards, I'm going to get the negative of this. Those are things that you have to remember. You can never change an angle unless you use an identity. Now remember I said earlier that the first thing you want to do is change everything to sines and cosines, but I also said there's an infinite number of ways to do these things, right? So I want to show you really quickly. If I change everything to sines and cosines, I'm going to end up with some nasty fractions. But you see how this is multiplication on the bottom? There's no adding or subtracting. There's subtraction in the numerator, but I can take each of the pieces in the numerator and put them over the denominator. And because the denominator only has multiplication, I can cancel. So I'm breaking my own rule here because this ends up being a very easy problem when it looked like a very difficult problem. Fearless and creative, right? There you go. Now, just for kicks, I'm going to do it the hard way, just to show you. So left-hand side, secant is 1 over cosine. I've already changed this right here, so I'm doing this. Minus 1 over the sine, all over 1 over cosine times 1 over sine. Now, fractions inside of fractions, I'm going to look at all of the fractions, get the common denominator, and multiply the top and the bottom by the same thing. Cosine x, sine x, cosine x, sine x. If you guys are uncomfortable with doing rational work with rationals like this, you need to go to the chapter in your book before the first chapter. There's a P chapter, prerequisites. There's a whole section in there about rational functions, rational equations, and operations with fractions is what it is. You need to go back and do those problems, read that section. You got to be able to get common denominators. You got to know how to simplify something like this. This is the easiest way to do it. Instead of getting a common denominator and then inverting and multiplying, I can just wipe out all of my fractions in one step. So this gets distributed to each piece. So when I take that and multiply here, the cosine is going to cancel, and it's going to give me plain old sine. When I distribute it to this piece, the sine cancels, and I'm left with the cosine. On the bottom, it's straight up multiplication. I get, when you multiply fractions, you go straight across and straight across, right? So this is just 1 over cosine sine, canceling cosine sine, which was the whole point, right? Leaves me with 1 on the bottom. Wasn't as hard as I thought it was. Sine minus cosine equals sine minus cosine. Fearless and creative, right, guys? Go for it. Okay, one more example. The book will tell you to work both sides of this. I don't want you to do that. You can work the second side on another piece of paper to figure out how to meet in the middle. In this particular case, the right-hand side looks awful. You could change the cotangent to cosine over sine, but what are you going to do with it then, right? So I want to work the left-hand side, and the only thing that I can do here is to get a common denominator. So my LCD is going to be one of those things times the other thing. But these are conjugates, so they're easy to multiply out. It's the difference of squares. I have to multiply this guy by this guy on the top and the bottom. 1 minus cosine. Big fat plus in the middle. I have to multiply this fraction by that guy over himself. Combine like terms on the top, and I'm going to get a 2 because the cosines subtract away. Multiply out the bottom. I'm going to get the difference of squares. But 1 minus cosine squared is sine squared. Okay? Now, what am I going to do with that? Well, this is when I'm going to come over here in my little thought bubble and look at the other side. That's 2 times. There's nothing else I can do to it. 1 plus cosine squared over sine squared. Leaving the 2 on the outside here. Common denominator is sine squared. Look, I'm almost there because I have a sine squared in my numerator. I have a 2, but where's the rest of it, right? So when I get my common denominator in the blue, it's going to be sine squared plus cosine squared, which equals 1, right? Thing is, this is 2 times 1 right here. So what I want to do, not work this and make them equal the way the book tells you to do, but I'm going to sit, what do I have to do to this to get it to look like this? I have the 2, I have the sine. Well, sine squared plus cosine squared equals 1, right? What I have over here is 2 times 1. I'm just going to replace 1, and this requires going seeing what the other side has. Sorry, there's a plus. And going backwards. Now what am I going to do? Well, let's look at what I did up here. This came from this, so if I take this, I'm going backwards now, and make two fractions. So sine over this and cosine over this. So I'm running out of room. I'm going to come up here and continue. 2's on the outside. I'm going to split that numerator up and write each term. And now I have a 2 times 1 plus cotangent squared. 2 plus 2 cotangent squared. Both sides. Okay? So sometimes you got to work from the bottom up and the top down and meet in the middle. And this is not very common where you replace the 1 with the cosine and the sine, the Pythagorean identity. But on a difficult problem like this, that's what you would do. Okay, if I had chosen to start with this side instead of this side, I would have done all this. Then I would have replaced this with the 1. That would have given me 2 over sine squared. I would have had to replace the bottom with 1 minus cosine squared, and then I would have had to do something called partial fraction decomposition, which you guys haven't learned yet. So working with this side was the only option with the tools that you guys have. Okay, try the homework. There's a lot of it, I know, but it's because it's important. The more you do it, the easier it gets. Pay attention to your strategy and always look for identities. Good luck, guys.